Hello everyone, my name is Harshita Singh. My roll number is 227034 from BSc third year. Today I am discussing here the topic finite state machine, transition state table and transition diagram, finite state automata and types of finite state automata. So let us start. So first of all, what is machine? Machine is a device that receives a set of input signal and produce a corresponding set of output. Next we have finite state machine. A finite state machine FSM is an abstract model of machine with a primitive internal memory. It has finite set of state. A finite state machine M consists of six tupples, that is, a finite set I of input symbols, a finite set O of output, a finite set of state, an initial state S naught. In S naught belongs to S, a transition function, and 6 is an output function G S into I is equals to O. The machine with six tupples M is I, S, O, S naught, F, and G. Now we will discuss about the transition table and transition diagram. There are two ways of representing a finite state machine. Transition state table. It is a conventional tabular representation of the values of next function f and output function g for all pairs of states and inputs. The first column in the table lists the present state. The second columns are element of input I given first under f and under g. The values of transition function f are shown in the first two columns under f, and the values of output function g are displayed in the last two columns of the table. So here you can see this is a table. So in the first column we are representing here the state S0, S1 and S2. Here this column f represents the input values and g represents the output values displayed on the G is the output values, and under F we have two columns that are the input values. Next, we will discuss state diagram known as transition diagram. The transition diagram is a finite directed graph in which each vertex represents a state that is in S. All the states are represented by a small circle. The initial state be shown by a circle with an arrow to it. The directed edges of a graph represent the transition of state and are indicated by input slash output a by x. So here we have S0, S1 and S2 are the states, and all the states are represented by a small circle. So here we have represented it inside the small circle, and while and we will the transition of state are indicated by input slash output. So here we and represents the transition of the state over here. Now we will discuss about the representation of SHM diagram from state table. So here we have given a table and we have to draw a diagram from it. So here first column represents the state. Represents the input. The last column represents the output. So we know that the states are always represented inside a small circle. So here we have represented S0, S1, S2 inside a small circle. So here we can see that it is a state S0. We are having input I1, so it state changes to S1. So we draw from S0 to S1 we have input slash output, that is O1. Then we have in S1 state we have input I1 is equals to S2. So you can see from here, from S1 to S2 we have input I1 and output O2. Then we have S1 in the I2 is S1. It means it has itself the input, so we represent I2 slash O2. Next is state S2 to input S0. If so it change it S2 to S0 we have I1, and I1 is the input and O3 is the output. and in state S2 we have I2 is equals to S1. So S2 to S1 we have I2 as the input and O3 as the output. Now we will discuss about the finite state automata. A finite state automation M consists of five tuples. M is equals to I, S, A, F, S naught. So I represents a input symbols, S represents a set of state, A represents subset of S accepting state, where fourth is a transition function F such that S into I is S, and S naught represents an initial state. Types of finite state automation. There are two types of finite state automation, that is DFA and NFA. Deterministic finite automata, non-deterministic finite automata. Deterministic finite automata DFA. The word deterministic refers to the fact that on each input there is only one and only one state to which the automation can have transition from the current state. We can represent a finite state automata using either state table or state transition diagram. The final states are indicated in state diagram by using double circles. State for which the last output becomes one are called accepting state. So here we have an example. We have S0, S1 and S2, three states. While applying input 1, we are having itself S0 state, and while applying input 0, we have S1 state. And in S1 state, while applying input 0, we have itself S1 state, and while applying S S1 input 1 to S1, we have S2 state. And in S2 we can see that while applying 0 input we have itself S2, and while applying 1 we have itself S2 state. So in deterministic finite automata, there is a one and only one state to which the automation can exist, can have transition state. So we can see that in if we have S1 state with the input 0, then we will have only S1 state. So this is a DFA. Now we will discuss about non-deterministic finite automata. Non-deterministic finite state automata NFA. There is another important type of finite state automation in which there may be several possible next state for each of input values and state. Such machines are called non-deterministic. So here we see the example. In S0 we have three state over here: S0, S1 and S2. While in state S2 we are applying input A, and we are having the itself is state S0. And here we can see that in this we are applying as input B to S0, we are getting S2. And in S2 we are applying input B and we are getting S0. So here the states are changing. There are several possible next state for input values. So this is an example of NFA. We can also see from here that it is S0 state, S1 and S2. Here we can see that we are applying from S1 in state S1 we are applying input A, and we get a second state S2. And in S2 we are applying input A, we are getting another state S naught. So here we can also see from here that we have several next states for each input. So this is also an example of NFA. Thank you.